So in this lesson, we're talking about bias. And by the end of this lesson, we want to understand what do we mean by bias when we're talking about statistics, or when we're talking about data collection specifically. And there are a few basic types of bias that are common in the data collection process or the sampling process. And we want to be able to identify what those types of bias are. Now, begin with, when we talk about bias in sort of general society, we sort of mean it to be equivalent with prejudice or discrimination or something like that. In statistics, it has a sort of a more specific meaning than that. When we're talking about bias in a statistical survey, we're talking about sort of any unintended influence on a data gathering method. Okay, so anything, to make it a little bit more general, we can say that anything that causes the measured values that you're trying to measure and you're measuring these things from your sample. So anything that causes the measured values to deviate from, and we'll put this in quotation marks, the true values. So the true values, remember, are what you would measure if you could do a census of your entire population. We usually can't do that, so we're taking a sample, and bias is anything that causes our sample measured values to deviate from what the true values would be in our population. So let's take a look at a few specific kinds here. Here's one, sampling bias. And sampling bias occurs when the chosen sample does not accurately represent the entire population. So let's take a look at an example here, and we'll discuss why there might be sampling bias in here. A survey asked students at a high school football game whether a fund for extracurricular activities should be used to buy new equipment for the football team or instruments for the school board. It says school board. I should really change that to be the school band. I'm not sure why the school board wants new instruments. So there is sampling bias occurring in this example. Let's first identify the population that is under study here. Who are we trying to get information about in this survey? Who are we studying? All the students at the school. Excellent. Now, our sample are these students at the game. So why is our sample likely to not be representative of the entire population, specifically with regards to the question that is being asked here? What do we think? Yeah. The people who are likely to show up at the football game are people who already like football, so they're likely to say, hey, we should spend the money on football equipment rather than on instruments for the school band. Now, we don't know that for sure. It could be that the school band always comes out and plays at football games. The football team might be really terrible, and the band might be really awesome, and people come out to see the band. But it looks from this that probably there would be a better way of choosing the sample where you didn't do it right at the event where the football team or the band were playing. Okay? So that would be sampling bias, because clearly these people don't represent all of the students at our school, at the school. Next type of bias here, non-response bias, when surveys are not returned, thus influencing the results. So let's take a look at an example here. A science class asks every fifth student entering the cafeteria to answer a survey on environmental issues. Less than half agree to complete the questionnaire. When they look at the results, the completed questionnaires show that a high proportion of the respondents are concerned about the environment and well informed about environmental issues. What do you think here? How is this an example of non-response bias? Well, first, a large fraction of the people did not complete the questionnaire. Less than half agreed to complete it. Okay. How do you think the fact that most people didn't respond to the survey has affected the results or the conclusions? Kel? Yeah, exactly. Only those concerned about the environment completed the survey. Thus, it makes the results look like everybody is well informed and passionate about the environment, when really you ended up choosing only those people bothered enough to fill in the survey. Okay, so all of those ones that weren't responded, that didn't fill in their survey, skewed your results. Let's see, household bias. When one type of respondent is overrepresented because groupings of different sizes are polled equally. Okay, now this is called household bias because you can imagine somebody doing a survey door to door. They knock on each door and they ask the person who answers the door some question, and then they say, well, in a certain number of households they answered yes, in a certain number of households they answered no, without taking into account the fact that some households might have one person in it, and some households might have 6 or 7 people in it. Okay? So we're not getting an accurate representation of all of the people because we're sort of sampling these things in different size groups. So how might this work in this example here? Each classroom in the school is asked to fill out one survey on students' opinions of changes to the flex day schedule. How could this be an example of what we call household bias? Okay? Yeah. Yeah, so if you've got a 30-person class versus a 15-person class, it's like everybody in that 15-person class, their opinion counts twice as much as everybody in the 30-person class. And you don't want that. Okay. We'll just say opinion counts 2 times with a question mark. Okay. So finally, I'll just mention this one here, response bias are factors in the sampling method that influence the results. So a lot of times the way the question is asked, or the way the question is phrased, or the way the survey is put together can influence how people answer the questions. Okay? And that's a separate kind of bias that can creep in when you're doing a survey. We're going to talk about that in much greater detail, though, in the next lesson on constructing effective surveys.